Hi, everyone. Thanks for joining us today for today's meetup. On today's agenda, Gert will be providing an overview of 3D solutions for proposed developments. And just as a reminder, we'll be recording and posting this meetup shortly after the meeting on meetups.com. During the meetup, if you would like to make comments or chat with other participants, then feel free to use the chat panel. However, if you'd like to submit a question for the team to answer, then please submit it through the Q&A panel. With that said, I'm going to go ahead and pass it over to Gert.
Thanks, Heather. Yeah, welcome everybody to this webinar on 3D solutions for proposed developments. What I would like to do today is go over three topics. First, I'd like to show you an example of how the solutions can be used. This is in Queenstown, New Zealand. And then we'll take a little bit of a deeper dive into all the components, all the workflows of the review proposed development solution. And then we'll also quickly cover the local government 3D Basemap solution, because the last one allows you to create 3D city models from your LiDAR data, building footprints, which is important too. So let's start with the example. So here we have a story map of Queenstown in New Zealand. And what we see straight away, we have a 3D picture or a 3D view of our city. And what we've noticed over the last couple of years is that 3D is becoming more and more important for local government. It is actually, what we see is that it's moving from nice to have, or it is cool, to becoming critical in decision-making process. And this is especially the case when we talk about planning, design plans, or proposed developments that will go up in the city. And why do local governments are kind of getting really interested in 3D visualization is that 3D is easier to understand, especially for the non-technical people such as the public and executives. And if it's easier to understand, that will lead to better communication between the parties and will lead to faster decision-making processes. So there is real value in displaying and visualizing something in 3D. So let's have a look and step through it. So what we see is that quite a few cities, they do already do review of a proposed development. There is a new greenfield or brownfield development going up, and they need to assess the impact of that development on the wider city scale. Now, there are a number of 3D impacts, if you like, that you can analyze and review with this review proposed development solution. So if we have a look at what is done traditionally, you see a 2D map, and then you see in red the location where, in this case in Queenstown, that new development is going to build. Straight away, if we look at it in 3D, it gives you a whole different perspective on that proposed development if you compare it to the 2D visualization. So here, this gray building that you see, that is the new proposed building that they are going to build in downtown Queenstown. So now there are a number of analyses that we can step through. The first one is a visibility analysis. What we do here, and I'll explain the colors a bit as well, is when you do a visibility analysis, one question is always from the public, from where can I see this new development? Will I be able to see it from my apartment, yes or no? And more importantly, how much of that new development will I be able to see? So what you see here color-coded from white to yellow to orange to red is the projected area of visibility that people will have looking towards the proposed development. So you can see, of course, that especially the folks here on the opposite side of the bay, they will get a lot of visibility of this new development. You can actually see here, it's called area project. That is the square meter of projected visibility that the folks will see from that location. And as you can see, it gives you straight away a very good overview of where this proposed development will be visible from. Another question when it comes to visibility is the other way around. What can I see from this proposed development? So you can say, you know, what is the lake visibility of the apartment, of these apartments in the block? And here again, straight away, you can see that the top floor has better visibility of the lake than the bottom floor. So that's, you know, one of the analysis of the solution. And later we'll do a deeper dive and I'll explain to you how you can calculate something. Another one is solar radiation. We've noticed that quite a few councils and local governments are interested in solar radiation. What we can do is we can calculate the solar radiation on the roof of this proposed building. So what you see here now is, again, going from red to yellow, is the solar radiation in kilowatt hours per square meter per year for this building. So instantly you can see where on the roof of this new building it would be beneficial to place solar panels. The next one is what we call shadow impact analysis. This is again, so the solution, this review proposed solution consists of 5 different workflows. This next one is called shadow impact analysis. And again, we got requirements from cities that it is important to know shadow impact of existing buildings, but especially of new proposed buildings on surrounding cityscape. So that could be a public park or a playground. And not only do we want to know, you know, where is the shadow going to be, but also how long and how much square meter or square feet is this new building going to cast shadow, so the extra shadow, if you like. And the solution allows you to calculate that as well. So we can calculate the existing shadow at a specific moment in time. So this is without the proposed development. You see the building is gone. But we can also calculate the shadows with the proposed development. Now this is pretty straightforward. Where it gets interesting is that we can calculate shadow differences. So here we calculated the extra bit of shadow that this building is going to cast on this specific moment in time. Now again, this is interesting, but what is even more interesting is we can do a cumulative shadow analysis, because then you can say on this given day, this building will cast 2 more extra shadows, for example. So the solution allows you to do that too. So this is the cumulative shadow map. So this is stepping through time on this particular day and recording all the shadows of the existing situation. This is before proposed development. And this is the cumulative shadow map with the proposed development. Now again, this is visually interesting to see, but what you're really interested in is the cumulative shadow difference. What is the actual new shadow over the course of this day that this building is going to cause? So that allows you to really, assess the impact that this building will have on this park, or like I said, on a children's playground or a school, or even on neighboring buildings, if you want to calculate that. And then another step of a development review process is, does this building, this proposed building, adhere to the zoning regulations? And this is not yet in the solution, but I still wanted to show you this. It is coming later this year, is that we can visualize the zoning regulations for the city. And that means this is the volume. In yellow, you can see the volume that a building can be built in. So if we get a bit closer, you can see that this proposed development falls exactly within the zoning regulations. So the maximum height, the setback, and the stepbacks are visualized by the yellow volume. And I can see that the building falls completely within the zoning regulation. So we're all good there. And then, so we visualized the development within the city. We ran a visibility analysis. We did a solar analysis. We did a shadow analysis. And we even checked if this building adheres to the zoning regulations. Next step, what we want to do is engage with the public and get feedback from the public to assess, whether this is a good idea, whether they think it's a good idea, or this is not such a good idea. So part of the review proposed development solution is an application, a web app called 3D Public Survey. Now this app allows citizens to participate in the planning decisions. So what we can do is I'll just fire it up. What we can do is we can ask the public a set of structured questions that you see here on the right-hand side. And then they will have the ability to answer the questions, again, with specific defined answers, and they can also do pre-commenting. And what you can do when you configure the application is that you can set up a number of viewpoints that you see here at the bottom. So just guide the user where you want them to go and make comments from. And then when they enter the application, so let's say I want some comments from this location here, they just simply go, do you like the size of the development? They can click yes, they agree with it. It doesn't block any of their own views, and then they can enter some free comments as well. And then they submit. So once they hit the submit button, we record the answers. And then what you see here are these colored symbolized points, if you like, with numbers in them. And the user can click on those, and then you get a pie chart of all the answers within on that specific location. So what you see here in this location is, yes, 5 people liked it, 2 are not sure, and 1 really didn't like it. And then the other thing, so you can really deep dive a little bit more into what the answers are. You can go to that location yourself and then see the responses that other people made. So you can see responses, and you can see that a lot of people put comments in. Oh, somebody put a comment in here, and I can see that they liked it, but the design, they weren't too keen on the design, etc. So this gives a real good feel for public sentiment. And we even color code the symbols to sentiment. So green means that a lot of people liked it quite a bit. If you go to more brown areas, there must be more people that didn't like it. There you go. See from this area, 10 people didn't like it, 5 people did. So instantly, you get a good feel and a good overview of what people think of this new proposed development. So that's kind of quickly going through the Queenstown example. And before we do a more deep dive into the actual components of the solution, we'll just have a look if people had any questions. So I'll give you a minute to see if you want to ask any questions about this specific example.
Sorry. There was one question, Gert, regarding the story map or the map journal.
Yeah.
Can you, one user asked if he could use it as a demonstration for his planning department. Can we give that URL out to?
Oh, yes, most definitely.
Okay.
So I'll do, actually quickly showed it, but I got the story map here, so it's in the call to action as well. But the story map here with the bit.ly is there, and it's all public, and folks can use it to demonstrate.
Okay.
I mean, unless you know a better way of sharing that bit.ly, maybe can we put it in the meetup? Maybe. Does that work?
You can put it either in the chat window.
Oh, let's do that.
If you can.
Where is the chat window?
It should be, yeah, down at the bottom of your screen. You should see it's by share screen. If you hover over the bottom.
I only get something at the top. Or is it here? Oh, here we go. It's hidden chat. Here we go. So there's the bit.ly, and that's the story map. So yeah, that's all public, and people are can use it.
There's another question. I expect we should see proposed options for buildings at a new location, such as heights or shapes.
Sorry, say that again. I missed that.
I expect we should see proposed options for buildings at a new location, such as different heights or shapes.
Yeah. So okay. So what you see here is only one option, of course. I mean, that's because I only added one model at this specific location. But you could load in 3 different models and then use the slide functionality to step through the different kinds of options. So that makes it very user-friendly. So you can see option 1, option 2, and the web scene would show the different options. So that's very straightforward to do.
Alexandria asks, is this a free application for the end user?
That's a good question, and yes, it is all part of the solution, which is free and or even open source. So you can take all the analysis that I showed, but also this 3D public survey app is all free to use for everybody.
Okay. Another question, does this involve the use of credits when performing various types of analysis?
No, the analysis that I showed are ArcGIS Pro analysis, which I'll do the deep dive in. So these are not online analysis at the moment. So you would do your analysis in ArcGIS Pro and then publish the results to your story, to web scene and subsequent story map.
Okay. Phil had a question. How do you obtain building data for more detailed roof shapes?
That is our 3D, our local government 3D Basemap solution. I'll get into that at the end of the presentation. But as you can see here, these buildings with the detailed roof shape, these have been automatically extracted from LiDAR using that local government 3D Basemap solution. So I will get into that as well, because yes, it's a big barrier to go 3D is your 3D based content. And we do have a solution for that as well, based on LiDAR data and building footprints.
Okay. There was, at the beginning of the presentation, there was a little bit of fluctuation in the volume. So we could hear you really well, and then it was kind of quiet. So I'm not sure if there's anything that you can do on your end. There was a comment about that. So
okay.
I could hear you pretty good, but there was some points where it kind of got a little quiet. So I thought I'd just point that out.
Just let me know and I'll shout a bit more.
Okay, sounds good. That's all the questions for now.
Okay, so that was the Queenstown example. So now let's have a look at how this was actually built and done. So when we hear, so this is just quickly, and again, since we're sharing the story map, all this information is in there for you as well. But the review proposed development solution is on our ArcGIS solutions.arcgis.com website, and here you have the 5 workflows, if you like, well, 4 workflows and an app. So visualize proposed development is actually how do I bring the development into my scene and place it. Visibility, of course, is what I showed you. You got solar, shadows, and here is this free app. So 3D Public Survey, you can download it here, and even the code is on GitHub as well. So now let's have a look at these workflows. These are ArcGIS Pro workflows. So you download the zip file, and then you get an ArcGIS Pro project. And this is the first one. This is Visualize Proposed Development. This is another city. This is actually what you get when you download. So you get free data as well. This is Naperville in the US. So you get the buildings, you get the trees, and then all the solutions are set up with tasks. Not sure if everybody's familiar with ArcGIS Pro, but within Pro, you got a really nice feature that is called tasks, which allows you to step through what is necessary. So if I say I want to add a proposed development, then you can see you can do it in two ways. You might already have a proposed development as a multi-patch, and you just simply load it in as you add your data from your geodatabase. So I can say I can just load that one, and then of course it gets placed here in my scene. But that means you need to have it already in your geodatabase, and most folks don't have that. So typically you get a model from an architect or from somebody else, and then it's just a 3D model, right? And you just need to place it in your scene. So that's also supported, and we just bring it into a multi-patch feature template. So there you can see I already placed the building in there. But if I go to my feature template and then say, click to select a model, then I can go and actually grab a model. Here we go, models. And Collada is the main, really the mainstream format, interchange format for 3D models. So you can just click it, and then you can place it anywhere in the scene. So I can say here, I want to place it there, and you just click it. So that is if you don't know where it goes and you just, want to bring it into the scene and place it somewhere. It's very, very simple, very straightforward. If your architect or somebody else already has location for the building, then it will load into the appropriate location as well. So I'm sure I can save it. So that means bringing the model in, and what you can see here now is that, just turn these off, is that if I show them all, we have a problem, right? And this is kind of interesting that it's different in 3D than it is in 2D, right? In 2D, you can just overlay layers and it kind of works. The top layer shows and the bottom layer doesn't show. Or you put some transparency on. And that doesn't really work nicely in 3D because objects are actually in each other. So this solution has a nice bit of functionality that I can mask existing features, which are my existing buildings, and then mask only the buildings that overlap with the proposed development. So I'll just quickly show you this one, but let's say my surrounding buildings, I want to mask with the proposed development, which is, let's do all buildings. And what the software then does, it simply just, well, doesn't do it now, but it should do. It will place a definition query on these particular buildings, and then the buildings are not deleted, but you will just see them disappear from the layer because the definition query is set. And then the second part of this solution is, so we just go, that you can publish proposed buildings to either ArcGIS Online or to Portal for ArcGIS. So there's tasks here that help you with that as well, make it really easy to publish. So that is just bringing the model in, placing it, and publishing it. The second workflow is the visibility one. So if we look at assess visibility, Again, task-based. So every project fires up and you go to your task folder and you fire up the task. And here again, you can see same data set, and I here have my proposed development. And then you have your task here, and you can say calculate projected visibility. Now these tasks are pretty handy because I can put a lot of help in here and a lot of example text, so you can really, it makes it easy to step through and you know what you're doing. So here we have our observer features. So that would be, let's say I want to know from this new apartment block, how much of the river can I see? How much projected square meters? This can be the river, but also, you know, we've had requests for property developments around Central Park in New York. You know, how much of Central Park can I see? And you can imagine the more you see, there might be more real estate value. So this is really a powerful analysis that allows you to quantify visibility of objects of interest. So if I say here, my observer, that's my proposed development, you can set a sample size. And if you do it, if you start off, you know, set a reasonably large panel size, because the smaller the panel size, the longer the analysis will take. But if I say, I just want to calculate 3 meters, what is a typical apartment size, 5 meters. And then I want to look at the river. And again, the river, you can set a sample size for as well. And then your obstruction features. So it's a very, very versatile solution in that you can say, I just want to look at surrounding buildings that might block the view. But you can also say, I need to take trees into account. And you can also say, I'm going to take the terrain into account. There might be a hill in the foreground. So if you let this run, typically it takes around 3 to 5 minutes with these settings, which we don't do now. You get the following result. Again, you will see this kind of panelization. And in this case, we panelized the whole building. And you see here color-coded. The more dark, the more area, surface area of the river is visible from that particular location on the apartment block. The solution also supports not only 3D objects, but also 2D objects. So I got also the road here. You can see this red line. If I want to know how visible that new apartment block is going to be from the road, I can calculate that in exactly the same way. So you can see here, it's pretty, I mean, it's all pretty straightforward and obvious, but you can see that we're quantifying it here in a nice way. So from this intersection, of course, I can see the new proposed development, but if I drive here, that building will block it. Here I can see a bit more, and again here, I will not be able to see that proposed development. So it's a very generic solution that you can do a lot with. The other one, for example, is you know, let's say I got my new proposed development here, and I got CCTV camera locations. You see here the red little points there, and in the circles, the brownish circles, that's kind of the radius of the camera. Again, I can calculate how much that camera can see, and from the position it's in there now. So if I turn that on, you can see here, again, yeah, my choice of color might not be the best always, but let's do it this way. You can see here that, you know, this camera here, where it's been placed here now is that, you know, if you go to the left and down, it's very light there, so it's not seeing anything there. Whereas this intersection here is actually quite dark green, meaning it's seen by 3 cameras. So again, this very quickly gives you a good overview of what potentially your security cameras will see around the building. So that is visibility. Let's go to the next one, which is solar radiation. And again, same pattern. It's a pro project that is built on tasks. So the task we have here is called Assess Solar Radiation. And what we've done here is a couple of things. So ArcGIS already comes with a solar radiation GP tool. And what we've done here is we made that more accurate by calibrating that tool with the NASA radiation data for variability. So that's at the moment it's a 1 grid size NASA historical data for 20 years that we calibrate the tool against. So the results that we get here are more accurate than what you get with the standard tool. What you can do here is, again, with lots of information in the task itself, and you can decide the features that you want to participate in your solar radiation map. So I want my buildings in the solar radiation map, I want my trees, and I also want my surface model. And you can set here again a resolution for your solar radiation map. And what you can also do is you can calculate for which month you would like to calculate the solar radiation for. You can do also all months. And when you do all months, then it will also calculate solar radiation for the whole year. And then you can imagine this takes some time. If you do it for a whole city or a whole county, it will calculate quite for a long time. But that's why we enabled the ability to do it selection-based as well. So if I say here, just calculate for this area, it will only calculate a solar radiation map for this area. And then the result, if we have a look, what you get is you get a solar radiation map. So what you see here is just a map of the surface. But as you can see is that behind the trees, there is less solar radiation. So it did take into account the 3D objects. And also you can see here behind the buildings, less solar radiation. Obviously from the south, there is more potential solar radiation than coming in from the north. And so that is calculating your solar radiation as a solar radiation map. The tool also allows you to visualize the solar radiation on the top of buildings, which is kind of nice. It's a different way of visualizing the results that you have. For some people, this is enough, just have the 2D solar radiation map. But you can imagine that you might want to see it on top of the buildings as well. So the solution has a task in there where we're actually visualizing the results of the solar radiation on top of our 3D objects. And then there's another task in here where I can also say I can draw a rectangle on the top of this building here, and I want to summarize all the results for this particular area. So what it does now, it just oh, I already ran that, so I can show you. It will do a summary for that whole area, and if you then click on it, you can see the total radiation in kilowatt hours per day for that area. So that gives you an indication of that selection area, how much solar radiation can I potentially get there. Let's see if we did everything here. Yeah. And then again, so I forgot this with the visibility as well. So every workflow has a number of tasks, and always at the end, there is the ability to publish your results. And again, task-based, it steps you through how to publish it and how to upload it to ArcGIS Online or portal, and how then to turn that into a website, which I will not go into now in detail. So the next one is shadows. And you'll notice the pattern is always the same. We have a pro project with tasks, and I'm going to step through the tasks. This one we did quite a bit of spend a bit of work on with a number of cities because every city has different legislation when it comes to shadow. So we really try to kind of what's the common functionality that is required. And what you do here is first of all we're going to calculate the sun position for the time that we're interested in. Again, you can say if this green area is the park that I want to know the shadow impact for, that is my observer. So I would put in the park. And then, the suns, that's my output feature class. I can set the time zone, which is for here, it is, Central Time. And you set your start date and you set your time interval. Now, when you run that, you get a bunch of suns. If we zoom out a bit, we see the suns in the sky. So this is the sun positions for that particular day. And these sun positions we're now going to use to calculate our shadow. And again, the same pattern here is as what you saw with the visibility is we're going to set our observer, which is our park. We want to know we want to know the shadows for this particular area. We can set a sample size. So that's the little squares of the result. I can set my sun positions. And again, obstruction features. So that same as it was with visibility, I can say which features will participate in the analysis. So for existing situation, it would be just surrounding buildings and the trees and of course the terrain. So I would run it, it would give me the shadow map. And then if I wanted to get the proposed situation, I just simply add that extra layer and then run it again. And then I get the proposed shadow map. Now for this, again, the bigger the area, the smaller the sample size, the longer it will run. Typically this, if you download the solution and you run it with the default settings, it's about 2 to 3 minutes. But the results are, and again, selection based. So if I select one sun or one particular time step, you can see here I selected a morning sun, I believe. Yep, so that's a morning sun. It will just select and run it for that time area, time step. Now, should I make sure that I pick the right one? Because otherwise it doesn't make sense. That was the one I ran before. But as I said, you can calculate the existing shadows. And this was kind of done at coarse resolution, just a quick and dirty, but you can see if there's no proposed development, I only get shadows from the trees, which is nice. However, if I do put the proposed development in, I will get more shadows on this particular time. This is 3:30 in the afternoon. And then I can compare, and that's an obvious one. That's the extra shadow on this particular time that we'll get because of this proposed development. Now, again, this one moment in time is interesting, but it's more interesting to do it over a full day. So you get a cumulative shadow impact map. This is the existing shadows. This is the proposed shadows. And it's kind of hard to really, what do I see here? So what you would want to do is do the shadow compare. And of course, we have tasks for this. So the create shadow tasks will create you the existing situation and the proposed situation. Then there's another task that will allow you to compare your base scenario with your test scenario. So if I would say base scenario would be existing and proposed. And in this case, I'm doing it at one moment in time, it's the 3 p.m. one. I would compare on a time step, not on hours, because if you have one time step, you don't have hours. So that allows you to just compare on one time step. And once you've done that, there's one extra tool in there that actually calculates the area of shadow that you might be interested in to say, let's say I got my shadow compare area and I want to know where the shadow difference is greater or equal than 2 hours. So now it would calculate the specific area where there is more than 2 hours of shade over the course of that day. And the result of that one is that one. So in this area, in red, I know that on that particular day that I calculate my suns for, there'll be more than 2 hours of shade caused by the new proposed development. So that is a really, a good result. All right, and then our final piece of the puzzle, if you like, is what we call our 3D public survey. So there's two components to a 3D public survey. There is there's the web app, and there's also a pro project that will create the point feature service that will hold the answers. And again, it's task-based, so it'll step you through how to publish that layer. So there is a configuration file, and that configuration file allows you to set what sort of answers, because it's a survey, right? It's not just free commenting. It does free commenting, but the main purpose is structured feedback. So the configuration file allows you to set the answers that you want to get back: yes, no, not sure. And also through pop-ups, you can set the questions that you saw earlier in the 3D Public Survey app. So this is quite not very exciting. You would just run this and nothing would happen because it only publishes a point feature service. So I won't show you that. But that is kind of the 5 pro projects that drive this review proposed development solution. All right, so before we move on to the local government 3D Basemap solution, I'll see if there's any questions.
Yeah, there's a couple of questions. One question is, can 3D satellite imagery be overlaid on various areas to show existing buildings?
Yes, of course. You can either use the Esri imagery Basemap, which comes with ArcGIS Pro and also in the web scene, or you can set up your own image service and load that in. So I can say, so with Pro, you have access to this imagery Basemap layer, or you can bring in your own imagery.
Okay. Next question from Alexandria. Do you get a sense that a lot of cities and counties have this data, not for new construction, but for existing buildings?
Yes, I get the sense that there is a lot of, so what I'll show you next is how to create this data, right? And what you need to create this data is LiDAR and building footprints. And what I've been seeing around the world is a lot of cities have LiDAR data and a lot of cities are building footprints. So it becomes very easy to get into 3D and create this 3D content using the solution that I'll show you next.
Okay. Another question, are these 3D analysis, 3D buffer, and 3D viewshed possible via the cloud on ArcGIS Online or server with prepared web scenes?
It is not yet possible doing it in web scenes, out of the box, I should say. But you could set up, if you had the in-house expertise, you can set it up as a geoprocessing services and then call those services from a web app. But that would be all custom built. But from a technical point of view, yes, it is possible to run the GP services in the cloud and publish it in the cloud and then bring it into a custom web app.
Okay. That's all the questions for now.
Okay. So yeah, so again, the thing that I see a lot of questions are is, it's all good and well what you're showing us, but we don't have any 3D data. And of course, that is the very valid point. And what we've created is what we call it the local government 3D Basemap solution. It used to be called local government scenes, but this basically allows it if you have LiDAR data, which a lot of cities have. So this is LiDAR data for this is classified LiDAR data, has buildings classified, but you do not need buildings to be classified in the LiDAR data. As long as you have ground classification in there, then it's good. And you have building footprints. So you see here now, the points. That's actually LiDAR points, which we now support streaming into web scenes, by the way, which is pretty cool. Then the local government scene solution or local government 3D Basemap solution allows you to extract from the data elevation and elevation surface automatically, but also 3D buildings. So these buildings, as you can see, have been extracted by the LiDAR. If we go very closely, you can see that we get a pretty good match. Of course, it's not perfect, but the roof detail that is necessary for these kind of analysis can be extracted from the LiDAR data. We do recommend that you have a resolution of better than 3 feet or 1 meter. So if your LiDAR data is 2 meters or 5 meters or 10 feet, then the quality of the extraction, you can imagine, is much less. But if you got 1 meter or 3 feet or better, then you can get these kinds of extraction results. And that solution also has the option to extract trees. Now, currently we just try and extract tree points and tree height, and we're working on extracting tree width as well from the LiDAR data, so that hopefully later this year that'll be there. And then, so these points and trees, again, what you see here, have been automatically extracted from the LiDAR data. And I can quickly show you. So this is, for example, the schematic local government scene. While it loads, I will show you here. No, not just yet. We'll show that later. I was going to show you the actual solutions side. So if you go to solutions.arcgis.com, there is planning and development option under local government. And there you will find the 2 solutions. So one is publish 3D scenes, and the other one is what we've talked about most, is review proposed development. If you go to publish 3D scenes, this is the solution that allows you to extract these features from your LiDAR data. And you can do it at 3 different levels of detail, as we call. If your LiDAR data isn't very good, you would stay at a basic scene, and that's just a simple scene. But again, it gives you your first step into 3D. Your schematic scene, that workflow will allow you to extract roof detail. And then we also have what we call a realistic scene. This is a workflow that allows you to, if you already have 3D data and you want to bring that into your scene, you might have good quality 3D data already for your CBD or for certain areas in your city, but the surrounding areas, the suburbs, you only have LiDAR data. This solution allows you to bring that all together. So your kind of lower level 3D with your higher level 3D. But if we look at what I've been showing you, that was done using the schematic scene workflow. This is this one here. Again, same pattern, right? We got tasks that, first of all, allow you to extract and publish your elevation layers, which in 3D, it's important that the buildings sit properly on the terrain, right? So we need to get those elevation layers as well. Then there is a task that allows you to extract the building roof forms from the LiDAR. And unfortunately, we don't have enough time to go through it. But you can always send me an email and I can take you through it online if you like. But there's a number of tasks in here. And one is to actually calculate the building roof form. So it takes the LiDAR data, building footprints, and calculates the the roof type, the eave height, the total height of the building, and the roof direction. So we know what kind of roof to put on there. And there is also a function in there that allows you to review the result of the extraction. And if the extraction hasn't gone good enough, there is a manual ability to enhance the extraction. So that allows you to, say if it put a hip roof on something and it should be a gable roof, you can actually in the solution say, no, sorry, this is a gable roof, and it would just switch it. So if you're interested in this solution, please contact me or somebody else in the team, and we'll take you through it. All right, so what I wanted to show you is, so you have your base scene, and then all your 2D data is not wasted or anything. You can bring your 2D data that you already have, your operational data, right into this 3D scene. And that kind of gives you a whole, gives you a 3D view of your 2D data, if you like. So in this case, I just brought in some points of interest, but you can see they're nicely labeled. You have fire station and your police. We can bring in our trail map and just drape it over in a 3D scene. Reserve land that the council might have. And again, it's not a 2D map anymore. It looks different than a 2D map, right? So some people like this 3D view, and it becomes very easy with the technology that we have today. So that is just, bring in your operational data, you have your 3D scene, and no problem, everything just can be brought in. And then that's kind of where I would like to leave it at. There is a coming soon there, but I don't want to get into that at the moment. I'd rather open it up for if there's any additional questions.
Yeah, there is a couple follow-up questions. Let me see. An example would be helpful, which shows the combination of 3D imagery overlaid with 3D modeling. Is that possible to show, or is there a website that people can go to get that?
Well, what is currently supported is that in 3D you can only drape the imagery on the surface, on the terrain. You cannot drape the imagery on your 3D models. So maybe I didn't explain that properly, but we cannot at the moment automatically drape aerial imagery on 3D objects at the moment. Okay. But just draping it on the surface is just loading the feature service, the image service.
Okay. Do roof type extraction, does LiDAR need to be classified to separate building or excuse me, let me say this again. Does LiDAR need to be classified to separate building and roof, or is it possible to extract from first return, for example, only vegetation versus ground classification?
You only need ground classification. So if your LiDAR has ground classification, then you're good to go. You do not need any other classification in the LiDAR.
Okay. A comment was it would be good to see satellite imagery overlaid onto LiDAR models.
It would be good to see, but again, that is not possible.
That's not possible. Okay.
No.
Another question. I understood that ArcGIS Online is not suitable for 3D ArcGIS analysis, so which way should I follow for 3D analysis on the web?
Well, as I said, ArcGIS Pro is really good doing 3D analysis. So the one way to go is to do your 3D analysis in ArcGIS Pro and then publish your results to the web. Online 3D analysis in the web scene viewer, that is something that we're working on, and that's definitely on the roadmap. And we will see, more and more of that capability appear in the next year and year after. But for now, I would say use ArcGIS Pro to do your analysis. That's what it's built for, and then publish it to the web.
Okay. Tom has a question. Is the ability to drape imagery on LiDAR models something that Esri is working on?
I'm not sure if folks are working on that. I could find that out.
Okay.
Yeah.
Is the tree data set file size very large in your content? And is there some tricks for shrinking the size so it doesn't use so many credits? Does it use credits?
No, this is just a seed service, so it doesn't use any credits. So I publish this, and then it sits there, and you just view it, right? That's how it works. If you were to cook this on the server, then the credits would be used. But if you cook it locally and then publish it, then there is not a lot of credit use.
Okay. Kyle had a question. Can you drape imagery over a tin model in ArcGIS Pro?
That's a good question. I haven't tried that myself, but I can find that out for you.
Okay. Charles has a question. Are the trees random, or can we place them via a point feature?
Well, what happened in the solution, so these trees are points. And the points have been extracted from the LiDAR. And if you are not happy with the point extraction, you can still move them around. But this is not random. This is done from the LiDAR. And we try to be, of course, extract as accurate as possible. So these trees are actually there. When you go to Queenstown, you'll see there's trees there on that location. So, and this extraction works really well in like an urban environment, not so much in a forest environment. So if you go up here, the extraction here is, I say the position of the trees is probably less accurate because it's a forest, whereas individual trees are extracted better. But if you're not happy with the location, it is a point. These are point features that you can just grab and change and then make it more accurate manually.
And to follow up with that, Charles just said, can you take us to Queensland to see the trees?
This is Queenstown, and here are the trees. Yeah.
One other question, are the capabilities of ArcGIS Pro and City Engine for indoor integration? Or what are the capabilities?
Well, we are working. So, to be honest, I think that's the very exciting area is indoor GIS, and we are working quite heavily on the ability to model interiors and analyze interiors and do interior network analysis. And in fact, at the Dev Summit, we'll release what we call a 3D campus example, which will allow you to bring in your CAD data, and it goes from CAD to GIS, and then we'll turn that into a 3D building with floors and allow you to automatically calculate interior networks, and then have a web app that will allow you to view that 3D interior and do routing within that web app. So at Dev Summit, if people are going to Dev Summit, or otherwise look at, when the proceedings are being posted, look for that 3D campus example, because that's our first step into interior GIS, if you like, in 3D, I should say.
Good. One more question. Do we use the 3D CIM or the 3D local government information model in an enterprise environment?
In a way, it's totally up to you. The solutions I presented today are agnostic. They're information model agnostic. The local government information model and the 3D CIM are I would say, 80 to 90% overlap. So, to be honest, there is not a lot of difference at the moment in them. So you're good either way.
Okay. Okay, so we're almost running out of time, so I'm just going to go ahead and wrap up. If you have any additional questions, oh, sorry,
Yeah,
I
so
kind of
this is
jumped the gun there.
that's my final question. So what I am looking for, what the team is looking for, is early adopters. So again, the solutions that are provided, and you see Queenstown was small. It's not necessarily that you need to be a big city. Small cities can work just as well with the solutions. But if you would like to go 3D, we put the offer here now that we would like to help you with that. So if there's any early adopters, please contact us, and we would like to get you up and running and help you, but also get feedback. And then contact information is you can contact myself or through the Zoom meeting. And again, as was asked before, that story map is public, and yes, you're free to demonstrate it and show it around. That's it.
Great. One last question I'll take. Is there any work done with universities that have Esri to include in their courses?
Yes, I can say yes, there's work done, but I'm not I don't know the details. But again, if you contact me, I can get you to the right person. And yes, but there is work done. Yeah.
Okay, great. I'll go ahead and wrap up. So thanks for joining us for today's meetup. We went a little bit over, but that's okay. We look forward to seeing and hearing from you at our next meetup, which will be on Thursday, March 23rd, so a month from today, which will be providing a comprehensive overview of the citizen problem reporting solution. So until then, have a great afternoon, everybody.